Ladies and gentlemen, I am Andy Cooper with Environmental Consulting and Technology Incorporated, otherwise known as ECT. We are a consulting firm with over 22 offices across the United States, and I'm based here in ECT's Chicago office. Thank you for joining us. This is lecture 2 of a 5-part lecture series on environmental law and policy. It's a basic overview of the underpinnings of environmental regulations in the United States. The lecture series is being hosted throughout the month of October this year at ECT. Our speaker is Mr. Mark Richardson, a former assistant prosecuting attorney for water quality in Macomb County, Michigan. Mr. Richardson is also an adjunct professor of environmental law at Oakland University in Southeast Michigan. Today's format is a 1-hour lecture with questions at the end, and we will focus on the Federal Clean Water Act. You're all welcome to post your questions in the chat box, and we will get them answered at the end of the lecture. To avoid any interruptions, I'll go ahead and mute all of our attendees. Thank you again for attending, and welcome, Mr. Richardson.
Thank you very much, Andy, and again, many thanks to yourself, Marcia, and Sanjeev for making me look a lot better than I have any right to look. This afternoon, we're going to be talking about the Clean Water Act. We're going to march through some of the basics of the act and wrap up the discussion with a little chat about the state of wetlands regulation in the United States. Before delving into the act, it would be a good idea to just briefly review the scope and nature of the water pollution problem in the United States. First remark I have is that probably the most dramatic impact on water quality in the United States is from a source that is not regulated by the Clean Water Act. That would be invasive species, and that's a whole different discussion. The Clean Water Act is designed to prevent conventional water pollution. And what are those pollutants? Excessive biodegradable organic materials, or BOD, primarily nitrogen and phosphorus levels, excessive sedimentation and siltation, excessive levels of bacteria and pathogens, legacy contamination by toxic organic compounds and metals, hydrological modifications, and excessive levels of salt, oils, and grease, primarily from roads. These are basic constituents of the water pollution problem in the United States. Where do these contaminants come from? This is an area where the picture in 2020 is different than it was in 1972 when the modern Clean Water Act was passed. Not that the sources have changed, but the significance of the sources has changed. In 1972, sewage treatment plants, power plants, and industrial sources were the primary culprits contributing to the water pollution problem, which at that time in this country was pretty severe, particularly in urban areas. Agricultural operations and urban runoff also contributed. Today, thanks in large measure to the way the Clean Water Act has operated, those are still our sources, but their significance has changed. Agricultural operations and urban runoff and storm sewers are much greater contributors to the problem that we face today. And as we'll see, the Clean Water Act has serious limitations in regards to addressing those particular sources. Just a word about severity of the problem. In 1972, about 2/3 of the nation's waterways were not considered fishable or swimmable. Today, it's about it's a little less than 40%, 36%. So there has been a drastic improvement, thanks mostly to the Clean Water Act. Next slide, please. Can you all hear me? Okay. All right. We've gone through this. Next slide. Thank you. I'm bad about slides. Okay. So how does the Clean Water Act, how is it structured and how does it operate to address some of these primary sources of water pollution? The most important thing to remember about the Clean Water Act is it divides the universe of water pollution sources in half. There are two spheres, and those spheres are called point sources and non-point sources. And I have avoided running legalese by people in these lectures, but I did bring in the definition of a point source because it's so very important and also illustrative. A point source is any discernible, confined, and discrete conveyance, including any pipe, ditch, channel, tunnel, conduit, well, discrete fissure, container, rolling stock, CAFO, that's confined animal feeding operation, vessel. So point sources include these kinds of sources, but they're not limited to these kinds of sources. As with any definition you'll find anywhere in the law, there are exceptions. And two major exceptions to this definition are agricultural return flows and stormwater discharges. They come from discrete points, but they are not regulated as point sources under the Act. The Clean Water Act regulates point sources effectively and thoroughly. It does a much poorer job of regulating non-point sources to the point where you can argue about whether non-point sources are really regulated at all under the Act, but we'll get into that. How does the Clean Water Act regulate point sources? Originally, the Clean Water Act relied on water quality standards as its primary enforcement mechanism, and the idea was to assess conditions in separate water bodies and design cleanup programs for those water bodies, which would in turn require all of the sources of contaminants in those water bodies to adjust their effluent. After a couple of years, it became apparent that this approach is too clumsy and unworkable to make rapid progress toward cleaning up water bodies. So it was essentially put on the shelf, although it was not entirely abandoned, and I'll actually return to talking about water quality standards in a little while. The primary strategy for regulating point sources under the Clean Water Act since 1972 has been uniform technology-based standards. When this strategy was adopted, the strategy of the Act shifted from focusing on ambient conditions, unacceptable conditions in the waters, shifted from that to the preventable causes of those conditions. Next slide, please. So, how does the uniform technology-based standards program, if you will, work? These are administered through permits, and the permits are part of a regulatory program called the National Pollution Discharge Elimination System, or NPDES. and the permits are referred to in the trade as NPDES permits. These are 5-year renewable permits issued to point sources, regulated point sources. And I want to explain what uniform technology-based permit, the words uniform technology-based really mean. The EPA has evaluated different kinds of point sources and has actually come up with a list of about 60 different classifications for point sources. And the reason it did this is because it's the effluent from different kinds of facilities is different, and the ability to minimize the pollution in that effluent differs depending on the kind of source that it is. So there's 60 categories of sources. And there are technology-based standards for each of those 60 sources. Now, what do technology-based standards really mean? They mean that the EPA evaluates a level of performance that sources of that type are expected to achieve. And that level of performance is based on the different pollution control technologies. And once it arrives at a level of performance that it wants to require, then that's included in the permits that are issued to these different kinds of facilities. The point I want to drive home is that the EPA and under the Clean Water Act does not prescribe technology. It doesn't tell sources it must use this or that filtration system or ultraviolet radiation or any particular type of technology. What the permits contain is a number. Now, the number itself is based on evaluating technologies and determining which ones are the best. But because it's just a number and not a prescription for a particular type of technology, sources can get to that number any way they choose. They can, an example might be instead of installing an end-of-pipe treatment system that produce the number that you got to comply with, you change your feedstocks. Maybe you're a chemical manufacturing company, and if you change your feedstocks, you can reduce your effluent limitations to the limitations in the number that you've gotten in your permit. Okay, so a little bit about which numbers the EPA requires from which facilities. The original 1972 Act divided all these different facilities into existing and new, and required existing facilities to comply with a less stringent number limitation than new facilities. And you're going to find this strategy throughout United States environmental law. It's a political compromise. It's based on political compromise and the idea that existing facilities are less equipped to retrofit themselves, that the economics of those facilities didn't ever include expensive pollution control technology, and the desire not to close down those facilities. New facilities, on the other hand, can be planned taking the costs of pollution control into account. So it's deemed more fair to require a more stringent number from new facilities. Okay, so existing facilities had to adopt a level of technology, uniform technology-based standard called Best Practicable Control Technology by 1977. And this basically means an average of the best available end-of-pipe treatment standards. And that term available means in actual use within industry, meaning that it's been adopted using cost-benefit analysis. And they were then to have upgraded to a more stringent standard by 1984, but in 1977, Congress got cold feet and backed off that requirement and imposed a different standard on existing facilities. And that standard is called Best Conventional Technology. And that standard, I should make this note, that BCT standard, Best Conventional Technology, doesn't apply to everything that these different classed sources put into the water. Just applies to a list of so-called conventional pollutants. And these are biological oxygen demand, suspended solids, fecal coliform, pH, oil, and grease, kind of a list of garden variety common pollutants. Those kinds of pollutants that come from different facilities have to be treated with best conventional technology. And what is best conventional technology? Essentially the same thing as that original BPT, best practicable control technology, that I discussed a couple of minutes ago. For all other non-conventional pollutants and all other pollutants that any particular type of facility would emit, the more stringent standard originally contemplated is still in effect, and that's called best achievable control technology. And that differs from the less stringent level in this way. The less stringent level is an average of the best performers. BAT, or best achievable technology, is the best single performer of that classification operating. So the existing facilities must match that best performer. For new sources, they have to comply with a set of standards called new source performance standards. And those standards are based on a level of technology called best available demonstrated control technology, or BDT. You really get into an alphabet soup of acronyms real quick in this field. BDT or zero discharge immediately when you go online. Now, there is a procedure in the law for getting a variance from that very stringent standard, but it's rarely used. It's called fundamentally different factors, and you have to apply for a variance, much like you would apply for a zoning variance in a different context. Okay, so today, an existing source would have to be a source that dates all the way back to 1973. Obviously, the more time goes by, the less sources are considered existing within the meaning of the Clean Water Act, and the more are considered new. So we're kind of gradually moving the ball toward the more stringent standards that I've described. There are, just real quick, a set of special standards for so-called toxic water pollutants. This came about as a result of a lawsuit in the mid-1970s, and the EPA has classified 126 different chemical compounds, toxic chemical compounds, as toxic water pollutants, pesticide residues, other byproducts of production. And there's a separate set of standards for those types of pollutants called best achievable technology. Best achievable technology is actually a little bit of a mysterious category. It's roughly equal to BDT, but the language of implementing it is a little bit fuzzier. So there's a little more variance in regulating those kinds of pollutants. So I need to talk about a special type of point source before I leave this area. And that's municipal sewage treatment plants. They receive NPDES permits. They are a point source. They have a technology-based requirement. However, I think it's fair to say that the technology-based requirement for municipal treatment plants is kind of frozen in time. The requirement for municipal treatment plants is based on secondary treatment. In a municipal treatment plant, you have 3 levels. You have primary, secondary, and tertiary treatment. And primary treatment is basically settling out solids from the sewage. Secondary is microbial treatment, the gazillions of bugs that attack the water and cleanse it, eat all the bacteria and a lot of the toxics out of it. Tertiary treatment is more advanced controls such as ultraviolet light, special filtration, and things of that sort. But from the standpoint of the law, the Clean Water Act, NPDES permits for municipal sewage treatment plants are based on secondary treatment. So that's been true since the beginning of the law. And I guess the reason for that probably is as much political and financial as environmental. Although it is true that there's been a tremendous cleanup of waste from municipal treatment plants over the years by imposing that standard. What time is it going to be? Now, I need to turn back to a discussion of water quality standards. I'll touch on, I'm going to say a couple more words about municipal sewage treatment plants. What about people that are businesses and people that are hooked up to municipal sewer systems? Obviously, they do not have to get Clean Water Act permits. They don't get NPDES permits. However, businesses that are hooked to municipal systems have to comply with standards nevertheless. And those are called pre-treatment standards. And those standards are enforced by the operators of the system. In the case of the Great Lakes Water Authority, formerly the Detroit Water and Sewer System, the pre-treatment standards are enforced through a Detroit municipal ordinance within the city of Detroit and various local level requirements in the other communities that make up the system. Those pre-treatment standards, I don't have time to go through them all, but basically they're directed at 2 things: preventing pass-through and preventing damage to the wastewater equipment. You want to prevent, you don't want to put things in the system that the system can't handle and go straight out to the open waters. You don't want to put things in the system that would cause a fire or explosion in the wastewater treatment plant. And that's what those pre-treatment standards are essentially all about. So now I want to move on to a discussion of water quality standards, which have always been a part of the Act, never the primary focus of the Act since the Act was amended in 1972. But what are they and what role do they play today? The Clean Water Act requires states to establish water quality standards for all of the waters within the individual states. And states do this by classifying the waters within the state depending on their intended use. And I've just, their designated use is the way it's called. And I brought Michigan's in since I live in Michigan as an example of this classification scheme. Michigan designates all surface waters of the state to protect all of the following uses: agricultural, navigation, industrial water supply, warm water fishery, other indigenous aquatic life and wildlife, partial bodily contact, recreation, fish consumption. And then it goes on to protect particular waters for other uses such as cold water fisheries, full body contact recreation, etc. States have considerable latitude to decide which water bodies to designate for which uses, but they have to, at a minimum, designate waters as fishable and swimmable at a minimum, because that's the objective of the Clean Water Act, is to clean water up to that point. So after this classification, what happens next? The states, again, are required to establish standards that would protect those particular uses. The laundry list of uses I just read off, you have to decide what is suitable water quality for to protect those uses, and that's where the standards are established, and they can be, most of them are numerical standards expressed as concentrations per unit of water. Some are narrative standards. The opacity standards pertaining to the murkiness of water is a good example of a narrative standard. But I brought in a list of water quality standards that Michigan uses. I'm not going to read them all, obviously, but just take selenium, for example. What is the water quality standard for selenium in the for the protection of indigenous aquatic life in the state's waters? Recall, I just told you that protecting indigenous aquatic life is one of the designated uses of all of Michigan's waters. Okay, so what is it? It's 5 micrograms per cubic liter of water, just as an example. There are many others. What happens after the waters are designated and the water quality standards are established? There are situations where even if you utilize a technology-based standard for within the permitting process, it might, for local reasons, result in the violation of a water quality standard. In that case, the water quality standards come into play, and the agency will write a standard, an effluent standard within the permit that may be lower than the technology-based standard in order to protect water quality. It may be that there are some contaminants for which technology-based standards, the existing standards don't apply to, and additional effluent standards can be written into the permit in that case to protect water quality. it is illegal to issue a permit under the Clean Water Act that would cause or contribute to a violation of water quality standards. So an NPDES permit at the end of the day can consist of both technology-based standards and standards based on water quality standards. And we have acronyms for those too. TIBLS and quibbles. TIBLS and quibbles. Technology-based effluent limitations. Water quality-based effluent limitations. Don't quibble with my definition of quibbles, if you please. Okay, moving on to our last two boxes down here. I mentioned at the beginning of the lecture that we still have about 36 to 40% impaired waters which don't meet water quality standards in the United States. That's a significant figure. What do we do about those dirty waters? There is a process for addressing that problem, which is a frustrating process, and that's called the TIMDL process. TIMDL stands for total maximum daily load. Each 3 years, the states are supposed to prepare a list of impaired waters called a 303 list for the section of the law it's named after. And then they're supposed to prepare essentially a cleanup plan for whatever contaminant is causing the impairment in a particular water. An example I'm familiar with would be E. coli contamination in the lower Clinton River. That stretch is impaired for that, for swimming because of that exceedance, high pathogens, bacteria. So the TIMDL plan would identify all of the sources of that contaminant and it would assign, it would allocate the responsibility for reducing the amounts of input amongst those sources. And once that plan is completed and approved, it's just referred to in the trade as a TIMDL. Well, what happens next? What happens next is essentially nothing. There's no mechanism in the Clean Water Act to actually make a TIMDL actionable. The hope is that once the problem is more precisely defined through a TIMDL, states will, on their own initiative, take actions to further clean up the waters. But this is an area of the Act which has kind of been in neutral for a long time. Occasionally, EPA comes along and makes people write a spate of TIMDLs. They vary in quality from state to state, from contaminant to contaminant. There's really no appreciable improvement in water quality as a result of this, and there won't be until these are made actionable and enforceable. Anti-degradation policy, I'm just going to mention very briefly. What about waters that are not impaired? What about waters that are better than the water quality standards? Do we allow industries to kind of move to those clean water bodies and spread the pollution around? Well, we're not supposed to. So the anti-degradation policy in the Clean Water Act divides the cleaner waters into 3 categories: Tier 1, Tier 2, Tier 3. Tier 3 are also called outstanding natural resource waters. And there's relatively few of those kind of waters designated throughout the states. Those are the highest and the best waters within states, and there's a reluctance to classify waters as outstanding natural resource waters because essentially you can't degrade them at all, meaning you can't develop around those water water bodies. Most of the cleaner waters in the United States fall within Tier 2. And Tier 2 permits degradation to a point below the water quality standard, by which I mean to a point where there's still no violation of the water quality standard, to, quote, as the regulation says, support important social or economic development. There's no definition of what those terms mean, and I've never been able to get any of the agencies to cough one up. Okay, well, we're running short on time. Next slide, please. Want to talk about wetlands in the time remaining. Wetland protection is kind of, I wouldn't call it a stepchild, but it's kind of like grafted onto the Clean Water Act. Clean Water Act Section 404 regulates discharge of dredged and filled materials into the waters of the United States. When you're talking about protecting wetlands, you're talking about protecting them from being filled. You're also talking about protecting them from being altered by dredging channels out of them and so on and so forth. I think we're all familiar with the ecological benefits of wetlands. I don't need to really talk about that too much. For historical reasons, the issuance of wetlands permits to regulate discharge of dredge and fill materials is the primary responsibility of the U.S. Army Corps of Engineers. Historically, the Corps of Engineers has always had responsibility for maintaining navigable waters of the United States, giving them the responsibility to prevent illicit dredging and filling of U.S. waters seemed like a logical move. Although they're primary, the EPA still has a role in issuing wetland permits. Next slide, please. I'm going to talk about a little bit about the history of the wetlands regulations, because as of today, the whole subject is just as legally elusive as it's been for years. In 2006, the Supreme Court, well, backtrack. What is the source of the controversy? The source of the controversy is how far does federal jurisdiction extend upstream? Obviously, if you're going to prevent a traditional navigable water of the United States, a Detroit River, let's say, from becoming polluted and contaminated, you need to have the ability to go upstream into the tributaries, into the headwaters, into the wetland areas that are part of that watershed to protect those areas as well. If you're talking about protecting a navigable water for not just navigation, but a variety of purposes, such as I just listed for you a few minutes ago, you're also talking about protecting wildlife and wildlife habitat. And how can you do that if you don't have the authority to regulate beyond what the actual navigable channel is? Well, you really can't. So courts have said that the Clean Water Act does permit the federal government to regulate waters that are connected to navigable waters. The bone of contention is, how much of a connection do you need? And the courts have gone back and forth on this. I guess I don't have time to explain the 2006 Rapanos decision in any detail, but that was a split decision for ruling against a claim of jurisdiction, for ruling for it, and the fifth vote establishing a kind of a separate test to determine whether wetlands, the USA had jurisdiction over wetlands or not. And 9 years later, the Corps of Engineers came out with a rule defining what it could regulate and what not, and it was based on that fifth opinion by Justice Kennedy. And what that wetland rule said was waters of the United States include waters with a significant nexus to traditional navigable and non-navigable waters of the United States. And the term significant nexus came right out of that court decision. The rule automatically classified certain waters as jurisdictional. They had jurisdictional. This is called categorical jurisdiction. And their basis was that they had studied all of the waters in these categories and determined that they indeed had a significant nexus. So this categorical jurisdiction was actually based on geography. And I'm running kind of low on time. I'm not sure I've got the time to go over what those are, but let me just give you a couple examples. 100 feet from the ordinary high water mark of a traditional jurisdictional water, within a 100-year floodplain, and 1,500 feet from traditional navigable water, within 1,500 feet of the ordinary high water mark of a traditional navigable water, and 1,500 feet from the ordinary high water mark of a Great Lake. Those questions won't be on the exam, but I throw it out there to illustrate the approach taken to this categorical jurisdiction under the 2015 rule. There were some waters not falling into these classifications where the Corps reserved the right to evaluate those waters on a case-by-case basis to again determine whether there was a significant nexus to navigable waters. And significant nexus didn't, it can mean ecological nexus. It doesn't necessarily mean a surface water connection. Okay, there's a change of administration. There's a lot of complaints about the reach of this rule. The classifications I just gave you, plus the ones that were decided on a case-by-case, gave the Corps of Engineers authority over vast amounts of water. So next slide, please. In response to those complaints, the Corps and the EPA rescinded the rule I just gave you and promulgated a new rule. And this is called the Waters of the United States Rule, effective this year. And what this rule does is it does away with the categorical jurisdiction scheme based on geographic distance from traditional navigable waters, and instead substitutes jurisdiction by definition. Under this rule, waters of the United States that can be regulated by the federal government include 4 specific types of waters: the territorial seas and traditional navigable waters, perennial and intermittent tributaries to those waters, certain lakes, ponds, and impounds, and wetlands adjacent to jurisdictional waters. And then it goes on to exclude 12 categories of water bodies altogether. And the most important, I'm not going to list all 12, but the most important are groundwater, no federal jurisdiction over groundwater, ephemeral streams and features that flow only in response to precipitation, and ditches, including agricultural ditches that are not traditional navigable waters and not constructed in adjacent wetlands and do not relocate a tributary of traditional navigable waters. Prior converted farmland and artificially irrigated areas, a lot of farm-related exclusions there. Do we need a surface water connection between a wetland and a traditional navigable water for that wetland to be regulated under the new rule? No, we don't need that, but we do need adjacency, and that's defined in this rule as abutting a traditional navigable water. How do you determine whether it's abutting? You do by reference to the wetland delineation that's done. If it's touching the traditional navigable water, the ordinary high water mark of that, it is considered jurisdictional. Remains to be seen, since this is a brand new rule, whose delineation is going to be acceptable. Leave you with this. This new rule is being challenged already in court, and nobody knows what the outcome of those challenges will be. Could be this rule is upheld. Could be the 2015 rule that I just gave you is reinstated. Could be both are deemed unacceptable, and a brand new third rule has to be written. This is a political fight. It has to do with allegations of overreach at the federal level versus a desire on the part of state and local governments to continue to be the primary regulator of water bodies within local communities and local areas, as it always has been. And I'm not here to comment on the merits of those political arguments, but the argument here doesn't revolve around ecology so much as it does who's in charge. So I am very sorry to have glossed over many of these areas. I'll be happy to answer any questions, but apparently I have to stop at this point. So thanks, and let's see if we have any questions.
Thank you very much. We do have one question that came in the chat, and I encourage everyone else, if you do have questions, please type them in the chat. The first one is, how are water quality standards established? And like X amount of Y is allowed in a certain amount of water, who determines that number is safe to humans and all the various species that may interact with that element?
Okay, I covered that really briefly in my talk, but those values are established by the states, and states go through a rulemaking process by which they evaluate all the available scientific evidence bearing on the effect of a contaminant on the designated use of the waterway. And I want to stress that the minimum designated uses for any state always include fishable, swimmable waters. That is that's the goal of the Clean Water Act. So in the example I gave you from Michigan, all waters of Michigan are designated for partial bodily contact, at least in the summer months. There are different standards for winter and summer, obviously due to the different uses that you make of water in the different seasons. So, but getting back to how they're established, review of scientific evidence, rulemaking at the state level. Rulemakings are formal affairs where all the stakeholders are invited in to submit evidence, and then the draft rule is announced, comments are taken on that, and then the rule are finalized. And the example I gave you is from the state of Michigan: chronic water quality values for protection of aquatic life in ambient waters. I didn't happen to pull the one that protects partial bodily contact, but as I said, these are narrative or they're numeric, mostly numeric. The ones I'm looking at are numeric for metals, and this happens to be all metals that I'm looking at from Michigan, but there are literally hundreds of different values protecting short-term and long-term exposure. as well as non-human non-human values of the ecosystem generally. So have I answered that question? I hope I
Thank
have.
you.
Okay.
Next one, describe the Rapinos case in a general sense, and why is it considered a landmark?
Rapanos and Carabel were two wetlands cases out of Michigan. And Michigan has actually been a source of several significant wetlands decisions. Rapanos was sued for illegally filling a wetland area that was 17 miles from the nearest navigable water. This was up in Bay County, Michigan. Carabel was desired to develop a wooded wetland which was adjacent to a navigable water in Harrison Township, Michigan, but it was separated from the stream by a berm, by an agricultural berm that had been constructed there over 100 years ago. So the cases were consolidated. The argument was that in Rapanos's case, the wetland was too remote from a navigable water to be federally regulated. The only connection between the wetland and the navigable water were some agricultural ditches which had been dug. In Carabel's case, he just said that there needed to be he argued that there needed to be a surface water connection between his wetland area and the tributary of the navigable water, which was the Salt River going into Lake St. Clair. These cases went to the United States Supreme Court, and the court, the four conservatives on the court held that each of these cases should be remanded because the wetland areas were not regulated. The conservatives held that there needed to be a continuous surface water connection between wetlands and traditional navigable waters, which was lacking in both of these cases. And the four liberals on the court wanted to uphold the previous wetland rule, which defined adjacency as just nearby a navigable water. So there was a 4-4 split on the fundamental issue in these cases, and the ninth justice, Justice Kennedy, he held that there didn't have to be a surface water connection. There had to be a, quote, significant nexus, end quote. And as a general rule, the court adopted Kennedy's test. They reasoned that Kennedy and the four liberals together, the five of them, stood for the proposition that there didn't have to be a surface water connection. So they ended up writing a rule that went into effect 9 years later, which didn't require a surface water connection, but was rather based on geography, like I said. So Carabel happened to be a case that I was involved in. I filed a brief with the Supreme Court, and I was pleased to have my brief cited in a couple of the opinions issued in that case. So there you go. Does that help?
Yes, thank you.
Okay.
One more. Can you generally again explain which of the waters of the United States definitions is currently in effect while the 2020 rule is being challenged?
To the best of my knowledge, to the best of my knowledge, the 2015 rule is still in effect because the 2020 rule has been temporarily enjoined by a number of different courts. This is it is probably unwise, though, to advise clients to just follow that they're guided by the preceding rule, because court decisions come down all the time, which change the picture. To the best of my knowledge, though, the 2015 rule is still prevails, while the 2020 rule is under challenge.
Okay, thank you, Mark. That's it, I think, for questions that have come in the chat. If there's any other questions, you can quickly add them. We'll give you a second here. If you do have further questions or comments about this presentation, feel free to reach out to me. My contact information is on the slide showing right now. Thank you for joining us. Next Friday, the topic is toxic and hazardous substances. So we'll meet back here at the same time. You should have the connection in your calendar to join that meeting next Friday. So Mark, thank you very much. Thank you, Sanjeev and Marcia. And we look forward to seeing you all again next week.
Thank you.